Just a minute to present you the screen. Last day we had started centripetal force. Let us continue with that. Okay, we have seen centripetal force is the concept when the object is in circular motion. The force that will act towards the center of the circular path, that is known as centripetal force. And the centripetal force depends on mass, velocity, and radius. The formula we have seen, mv square by r. Any force that is acting towards the center, that is the centripetal force. I have seen few examples also. Now the next topic is centrifugal force. I think last year we had started, and centrifugal force will act right on the object in non-inertial frame. Mean to say, you can see on the definition, an object in a rotating frame experience an outward force. Right? An object must be placed in a rotating frame. I've given one example yesterday that a car is moving in a circular track. The car is moving in a circular track, so centripetal force will act on the car. But any object or any passenger sitting inside the car, an outward force will act on that person or passenger, and that is the pseudo force, or you can say that imaginary force or fictitious force. It will act on the object inside the rotating object. Okay, and that force acting, that imaginary force is known as centrifugal force. See few points about centrifugal force. First point you can see, centrifugal force is not a real force. Already I have said it, it is imaginary, fictitious, virtual or pseudo force, anything you can say. Second point, magnitude of centrifugal force may be same as that of maybe. It is not necessary that centrifugal force and centripetal force will be equal. It may be same. Third point, centrifugal force is not the reaction force of centripetal force. Right? Centripetal force acts towards the center, and centrifugal force acts outside or away from the center, outward direction, but they are not action reaction forces. And the last point, centrifugal force is always in outward direction. Okay? Is it clear to all of you?
Yes, sir.
So why is it not an action reaction force?
Because they are acting at two different objects. Okay, and they may not be equal. This is all about centrifugal force. Okay. So let us go to the next slide. Any question about centripetal and centrifugal force? is moving in a circular path. This is a circular track. An object, suppose a car here, or any object is moving in this circular track. Okay. Now, the car is moving in a circular path. So already I have stated centripetal force will act to the car and it is towards the center of the circular path. And any object inside the car is rotating. So any object placed inside the car, okay, on that object, centrifugal force will act and that will be away from the center, this side. Okay, so remember this is the centrifugal force. This is the centrifugal force. Okay, understand? The force is not tangential. If you give the direction of force along the tangent, this, so this will be wrong. This is not the direction of centripetal or centrifugal force. ठीक है, इस तरह का कभी गलती नहीं करना. There are few questions. All of you, please write down these questions and try to solve it. Question number 1. Give an example of motion in which speed remains constant but velocity changes.
Circular motion.
Uniform circular motion. If an object is moving in uniform circular motion. Good. Please note down these questions and write down the answer. Question number 2. A uniform circular motion is an accelerated motion. Explain it. Anyone? Yesterday, few of you have explained.
So may I? So the uniform circular motion is an accelerated motion because its speed remains constant but velocity changes with change in direction.
Velocity changes because the direction of velocity changes at every point. Okay, good. So velocity changing, it means this is accelerated motion. Okay, ठीक है. Third, name the force required for circular motion and state the direction.
Centripetal force, it is towards the center.
Centripetal force, it is towards the center. Good.
Why not both centripetal and centrifugal?
Again, you are confusing. Centripetal force act on the object which is in circular motion, right? But centrifugal force will act on the object which is placed on the body which is moving in a circular path. कार जो है एग्जाम्पल कार वाला car is moving, right? So centripetal force acting on the car. But inside the car, if any object is loosely attached, the centrifugal force will act on that object, not on the car. Fourth question. Name the source of centripetal force in the following. An electron revolving around the nucleus.
Electrostatic force of attraction.
Electrostatic force of attraction between
The negatively charged electron by the positively charged nucleus.
yes. Electrostatic force of attraction between the nucleus and the electron. Revolution of Earth around the Sun.
Gravitational force of attraction.
Between the Sun and the Earth. Fifth question. A stone tied at the end of a string is well in a circular path. Name the force acting on stone and on the hand. Name the force acting on stone and on hand.
Sir, on stone it is centripetal and on hand it is centrifugal.
Yes. On the stone is moving in circular path, so centripetal because of the centripetal force, right? And what is the source of centripetal force? Is the tension along the string, and so the hand, the tension is active. So all of you, stone, the answer is centripetal force, and the answer is tension. Is it clear? Fifth answer to all of you. Why not tension on the stone? Anyone? The tension along the string provides the centripetal force. Okay? And tension is mutual, all of you know. So tension will act on the hand also. The tension acting along the string towards the stone, that is the centripetal force, and the tension, one more tension acting to the hand. Question number 6. A pebble tied by a string to its center, okay, is placed near the periphery of a circular disc. The disc is rotating about an axis passing through its center. What will be your observation when you are standing outside the disc at the center of the disc?
When we will stand outside of the disc, we will observe that the pebble will move in a circular path.
Yes. And if you are on the rotating disc,
The pebble is stationary.
this is the question, okay? number 6. Pebble tied by a string to its center is placed near the periphery of the disc. The disc is rotating. This is the disc rotating about an axis. Suppose this is the axis. It is rotating, suppose anti-clockwise direction, any direction you can give. The stone is near the periphery. Stone is here. This is the stone. Now you are outside. Outside, your position is suppose in the box. So what will happen? What you see? What is your observation? Once again, see the question. The pebble is attached with the string near the periphery. The disc is rotating. What will be your observation? क्या देखोगे? When you are standing outside the disc, you are standing here outside. So what will observe? The stone is moving with the
Circular motion.
circular motion. It is on the disc, so stone will move in a circular motion. That's all. Is it clear? Now you are here at the center of the disc. It means you are also rotating. The disc is also rotating. Pebble is also rotating, like us. Right? The earth is rotating. We are on the surface of the earth. But what is our observation to other objects? The objects you see around you are at rest. Okay. So when the person will be at the center of the disc, his observation towards the pebble is that the pebble is at rest. Okay? If you go to space, and suppose it is possible to see the rotation of the earth. Okay? So you'll observe that the objects on the surface of the earth is rotating with the earth. But as soon as we come on the surface of the same objects, what you'll see? They are at rest. The second answer, when you are at the center of the disk, you see that the objects are at rest. Okay, the pebble is at rest. Is it clear to all of you?
Yes, sir.
Okay, now listen all of you. In the same question, on this question only, if I cut the string, somehow, if you cut the string, then what will be the observation when you are outside the disc and when you are at the center of the disc? ठीक है, अगर कट कर दिया जाता है तो क्या देखोगे? ठीक है, so think it about it. We'll join after 5 minutes. Okay, I'll giving you 5 minutes time to think about the question. Okay. Anyone would like to answer this question? No, the pebble is moving in a circular path. Right? Any object moving in a circular path, and if there is friction, if the object is fixed on the disc, pebble is rotating with the disc. So, if the support is released, so obviously the stone will move in a tangential path like this. there is no friction, only the tension is acting. And if you cut the string, in that case, the pebble will move in upward direction because of the centrifugal force. Okay. So let us solve few questions from the book. All of you try to answer it. These are the questions from book. The first question is centrifugal force a real force?
Sir, it is not a real force.
It is not a real force. Now, next is the earth moves around the sun with a uniform velocity. True or false? The earth. True. Okay. Listen the question. The earth moves around the sun with a uniform velocity.
False, sir.
False. Because you know that the earth is moving in a circular path around the sun, and so at every point the direction of velocity is changing, so velocity is changing. So velocity is not uniform. This is false. Next is the motion of the moon around the earth is circular path. In circular path is an accelerated motion.
Yes, sir.
All of you listen once again. The motion of the moon around the earth in a circular path is an accelerated motion. It is? Yes, true. Moon is moving in a circular path, so obviously the motion will be accelerated motion. Next is a uniform linear motion is unaccelerated, while a uniform circular motion is an accelerated motion.
Sir, because linear circular motion. True.
Yes, true. The uniform linear motion is unaccelerated. Uniform linear motion, velocity constant, no acceleration, so unaccelerated. And,
Yes, sir.
yeah, and the circular motion is accelerated motion. Next is in a uniform circular motion, the speed continuously changes because the direction of motion changes.
False. False, sir. Speed remains constant.
Speed remains constant. Okay. So this is all about centripetal force. Mainly centripetal force is our topic. Right? Now question to you all. To load a truck, heavy loads are there and empty boxes, light boxes are there. Which will you load first? Heavy boxes or light boxes? And why? While loading a truck, what will you put first? Heavy boxes or light boxes? All are of same size. And why?
Heavy boxes.
Why?
Because after we put the heavy box, we have to put the light box above the heavy box. So more force will be required in raising the heavy box to the height, while less force will be required to raise the light box to the same height. We have to raise the heavy box to lesser height than that of the lighter box.
Okay, listen all of you. Okay, before I answer this question, what is the wrong concept? What you have said, just I want to explain it. Then I'll come to the answer of the question. Now this is the surface. This is an object, heavy object, suppose heavy load. This is a heavy load. So mass is m, right? its mass is m, or weight is mg, whatever it is. To lift it from the surface, how much force is required? How much force is required to lift it?
Mass into gravity.
That is mg. Right? So to lift this object, the force required is mg. Okay?
Yes, sir.
Yes, sir.
Okay. Whether you want to lift it by this height or this height or this height, every time force required to lift it is mg. So whether you lift the heavy load to high altitude or low altitude, the force required is same. But energy required is more when you lift it to a higher altitude. Potential energy mgh, mgh. mg same, h is different. So I haven't seen who has answered this. So one clarification that while lifting a heavy load, same force is required. Now I'm giving you a clue to answer this question. This question is based on the topic center of gravity. नहीं होगा? Okay, once again, listen all of you the answer. We'll put the heavy loads first. Okay. Reason is that the center of gravity shifts towards the heavier part of the object. Like all of you see, I'm putting this is the heavy load, the black one, and this is the lighter one. Where is the position of center of gravity? I'm giving you some diagram. You have to locate the center of gravity. Okay, first case, where is the center of gravity? First diagram, two black boxes
Sir, in the middle.
in the middle, somewhere here. Here to our where is the center of gravity for the third figure? Two empty boxes
Sir, same in the middle.
in the middle. Second diagram. Where is the center of gravity?
Sir, below the middle.
Like
Below the middle, somewhere here. And the last case. Center of gravity is in the room.
Sir, above.
Somewhere here. We can see that four diagrams. So in second case, the center of gravity is at the just above the baseline, just above the surface. You know the position of the center of gravity is lower. In that position, the object will be stable. ठीक है? Center of gravity जितना नीचे होगा, the object will be more stable. So out of these four cases, in second case, the center of gravity is lower, so this arrangement is more stable. So that's why you have to place the heavier boxes first, then the lighter one, so that center of gravity will be lower and the system will be stable. Okay? So whenever in our home also, whenever we want to put the objects, heavier object first, then the lighter one, so that the system will be stable while the center of gravity will be lowered in this case. In these four cases, which one is most unstable?
D.
D, last one. अगर lighter boxes पहले रख दिया और ऊपर heavy boxes रख दिया, then the system will be most unstable. Okay, this is clear, I think. So this is the end of the first chapter. Anyone would like to ask any question?
Sir, if we give the answer of this question same as the first answer and change force with energy, sir, then will it be correct?
No, this is the concept is center of gravity, not don't answer in terms of energy or force.
Sir, please explain the last point of center of gravity.
Last point means last diagram.
Sir, the last point you have written. Sir, wait a minute.
Sorry, sir, but I may not follow anything.
What is your problem? Question.
Sir, that the load one you are telling I cannot understand.
The heavier load should be put first because in that case center of gravity will be lower. Okay, and so the system will be stable. That I have explained. Okay, center of gravity जितना नीचे होगा सिस्टम उतना स्टेबल होगा.
Sir, the last point, the
Center of
algebraic.
gravity last.
Yes, sir. The algebraic sum of moment of force due to weight of all the particles of the object about CG is 0.
Last one, the algebraic sum of moment of force due to the weight of all the particles. What is moment of force? Moment of force.
Force into perpendicular distance.
Force into perpendicular distance. Take an object, right? So take an object. Suppose this is the object. It has so many particles. This is one. This is second. This is third, and so many particles. I'm taking three only. Center of gravity is at the middle. Suppose center of gravity is at the middle, somewhere here. Suppose the red point, okay, is the center of gravity. So weight of the rightmost particle, its weight will be downward. This is the weight. Okay, W, I'm giving you W. That is the force, weight is the force. And perpendicular distance from center of gravity is this distance. Okay, you can see line. So moment of force of that particle is perpendicular distance, suppose v1 into w. Let us take another particle. Its weight. Generally, all the particles have the same weight, taking w, and perpendicular distance of this particle from the axis of rotation or from the center of gravity is this. I am taking the third point. Its weight w and its distance from the axis of rotation or from center of gravity is almost this distance. Okay. So find the torque of all the particles. How many particles are there? In this diagram I have shown only 3. But in any object, how many such particles are there? In numerous. So not possible to draw all those particles. So imagine there are so many particles and the moment of force of the torque of all the particles you can find in this way. Now if you add all the torques, few will be clockwise, few will be anti-clockwise. If you add all these, then your answer is 0. Your answer will become 0. Okay. So about center of gravity, moment of force of all the particles, if you add them, sum them, the net moment of force will be 0. Okay? So in this diagram, I have taken only 3 particles. So you have to take infinite number of particles. So which is impossible to draw. So but if you find, the answer is 0. Why it is 0? Because at center of gravity, the object balances. Balances means net clockwise torque and net anti-clockwise torque must be equal, and that's why they are balancing. So net moment is 0. Take care.
Yes, sir.
Okay then. Thank you. Thank you very much. Have a good day.